and go back to the assignment. I'll quickly go through this. So you're going to build a shell, learn lots of stuff with syscalls, going to work with strings, and see if you know enough C to take the rest of this course. So you will be working on this in a number of steps. So we kind of break it down into manageable parts. So first, you'll work with just making a prompt, right? You'll just print the current directory, and there's a library function for that, and followed by $, kind of like bash, right? So your current directory $, right? So you know where you're working, and so it'll print a new line and exit without any user interaction, right? So it doesn't need to do anything, right? It doesn't even loop, right? It just prints the current directory and then exits, then prints the current directory and then loops until it gets Control D, right? Kind of like bash or sh. And when it exits, it returns with 0 as opposed to a non-zero exit code, which would indicate an error of some kind.
Joel, one thing. Do you want to show them the man pages, just like how they work and how to?
Yeah, I might as well look at some of the man page stuff. That's useful. And
like you just take like get CWD or something as an example.
Yeah. So let's look at, so first of all, for anyone who isn't familiar, on Linux, you can use, ignore that, that's something completely unrelated. In Linux, you can use the command man, to get information about some command. So it looks like Ian's hand is still raised. Let me just lower it because I think we've answered that question. So in Linux, the man command can be used to get information about a command. So like man bash, get information about bash, man, pwd, print the name of the working directory, right? And so this is, you notice there's like numbers in the manual pages. And this, when I was first learning Linux, this was confusing for a while because I wasn't even sure what to Google. But it looks like, or it turns out you can just find information about this by doing man on the man command itself. And it's got a list right here. So let me make this easier to read, hopefully. Oh, got another one up here. All right. So it is a system manual pager. So it'll, take files that are in this format called troff, or I think like there's a program called groff that'll do this formatting, and it'll show them, using these protocols. So there's 9 categories. Usually you only deal with like 3 or 4 of them, maybe. So the first one is programs or shell commands. So like as we saw before, we had man pwd, right? It had a 1, right? And so that's a shell command. System calls. So if we wanted to look at the the open system call, let's say, we could do a man to open, right? And now we're looking at specifically the system call, like not the any kind of command, right? And I'll tell you about the headers and the way the system call is supposed to behave. Library calls, so functions with program libraries. You know what? I can just do this. Library calls. So man 3 open. Oh, that's not what we're looking for. Let's say man 3, write. Right. So now we're looking at the glibc.
A little small for them. I don't know.
So is this still small? Is this good?
It's probably, I don't know. I'm just guessing.
Kind of paged weirdly. Is this still good? A little bigger? Right. It just gets kind of,
He's saying it's good.
You could try closing and reopening the thing because it may page based on the initial size.
Yeah, it's not a good point. Yeah. So right now it's telling us about the interface and specification of the write command for it's implemented for glibc. So behind the scenes, this is just going to call write. I mean, there's also, I guess, a p write. That's part of the and this is part of the POSIX programmer's manual. So Linux may be different than the actual Linux implementation may be slightly different. So if we look at like man 2 to the right, we can look at the actual end system call with Linux, right? This is used where it actually interacts with Linux. You will be working with this interface, which is it's slightly different. You just have the right system call. You have the prototype. You have the return type, the include. The include that you need to use. Uni STD, like Unix standard, I think is what it stands for. And see, it's just write to a file descriptor, and it's in section 2. You can call right up here, and you can read this when you need. So this is slightly different, but the wrapper will be, I think it'll roughly like wrap this behavior. So you notice this is POSIX, right? It doesn't say like glibc or something. So POSIX is a standard for systems programming, basically for how computers can behave, and a lot of computer systems roughly implement this standard. I mean, I don't know, Charlie. What would you say is important about POSIX in like 2 sentences?
POSIX is, I think it's like a government standard, right? Like I think it was something that, it's portable, open, like portable operating system interface or something like that.
Yeah.
Like Unix on it because they wanted it to sound like Unix. Like I think all major operating systems have some level of POSIX compliance. It basically sets out things like capabilities, but it doesn't necessarily. Some functions are required. Other things, there just needs to be a way to do certain things. And it just means that like if an operating system is POSIX compliant or POSIX compliant, then I don't know. There are certain functionality available. It's just basically a standard that operating systems can adhere to make code portable between multiple platforms.
Mm-hmm. Yep, pretty much. So something good to know about what it generally is. I mean, you don't need to memorize the standard, but you'll probably see it around when you're doing systems programming. Anyways, yeah, that's section 3. You can see the other one that's interesting is, this is man 1, but section 7 actually. You do see some things in section 7, so macros and conventions. So like, I think if you like man like ls or no, like what's one that's in section 7? Man like 7 man. I think it was saying man was going to be here. Man 7 man. Yeah, so it is. Yeah, macros to format man pages. Interesting. So I don't know. Maybe if I just do man 7, is it going to tell me interesting? What manual page do you want from section 7? Oh, interesting. I do a star. I'll just say a man libc. It'll, there's also, I see we're looking at all the man pages. So next one, man pages. And now, okay, it's trying to open up a man page for every file that's in my directory. That's what it's doing. That makes sense. Man. I don't know what would be an interesting man page. Well, let's look at the ones that were on that at that shell list on that list. Let's see, where is that? Here we go. So man get CWD. Okay. So make this smaller. Get current working directory. So you can use this in a C program if you have before. Simply include unistd.h, and then you can use these prototypes. Get CWD, you can pass a buffer and a size, and that'll just, that'll put it into the buffer. I guess this will do something similar, but without a size. I bet that's probably not as good of an idea to use. And it looks like this one, you don't even pass the buffer. It'll just give it to you. But I guess it's probably a read-only string. Get current dir name. That's an interesting one, huh? I should probably just use get CWD.
Yeah, the one that you pass a buffer to, yeah.
And the size, that's probably the safe one. So get current dir name. It'll malloc an array big enough to hold the absolute path name of the current working directory. Interesting. And then you need to free it later. So that's an important thing to know. I mean, you could use this one if you want. I mean, it's not the end of the
It's
world.
less portable, I think. Like, I think that's
If you have memory
basically-
errors, that will count against you. So they should be sure to use Valgrind. You should all know how to deal with memory errors at this point. And if you don't, then look into it.
No memory leaks. Yeah.
No memory leaks. Memory leaks will count against you. So what else? Yeah, I don't know. Get CWD. So functions exactly as expected. Copy is the path name to an array pointed at by buff, which is of length size. So pretty straightforward. You basically write a thing that prints that. So then you get it to loop. You get it to print unrecognized command. If you type something in, or nothing, if you don't type anything in, then you can break it down into different pieces. So you can include the name of what you said, right? If you did say, if you type multiple things in separated by spaces, it'll print the first one, right? So like cat shell.c, we'll print unrecognized command cat. Then you implement a couple of built-in. So exit will just exit with whatever return code. No, it takes no arguments actually. So I just exit with the return value of 0. I mean, you could, I don't know, you could like add some
Yeah, you definitely can.
things to some of these functions. Like you can add functionality if it doesn't contradict with anything here. If you think of something cool, or if you think something you want to implement, I mean, go nuts. Like this is pretty bare bones. Takes CD, just changes one argument using chdir. Changes directory, takes one argument, so we can show that. It's kind of annoying, huh? And to dir, change working directory. And so actually 2 versions of it. fchdir, it's kind of interesting. So chdir, you just pass a path, as you would expect, a path, Linux path. fchdir is identical, but only difference is that directory is given as an open file descriptor. So you can open a directory and you'll get a file descriptor, right? Using
open.
Yeah, I mean, you can pass a path name and open a, let's see if it says something. I think there's some special thing for like directory. Directory, right? File creation. So if you're creating a directory, like you can create a directory with open, or just open it. And then you'll get an integer. Yeah, path name. Oh, here we go. Yeah, path name. So you can say, if it's not a directory, make open fail. There's also an open dir command. Which I guess man3 open dir. Interesting. Or fd open dir. Open it from a file descriptor. And we'll get this will give you a dir structure. Dir star, which is I guess similar to a file star, which you may have worked with in other courses. But I don't know. That's just that's an interesting variation. You probably don't want to use this one. You probably just want to take the path that's passed in as an argument. I just pass it into chdir and then deal with the return value here. If you are not familiar with Erno, you should become familiar with Erno. So it's the number of the last error. You include it with erno.h, and then you can use it to, well, you don't actually use Erno directly. What you usually do, this will be like the system call error. Like sometimes you see like program error, invalid write, or out of memory, or these things. Like those are the standard numbered errors that are saved in Erno. It's a pretty standardized thing, right? Erno, you can actually see the list of them, right? So Erno-L. Oh, I guess we don't have it, but it's telling us here. If you have the Erno command, you can see these things like eperm, operation not permitted, no such file directory, no such process, interrupt the system call. So these are standard things, right? These are values or other macros that you can use in a program. And these are the messages that you may or may not have seen when using Linux for various things. So it's actually probably, you can probably get Erno if I don't have it. command 3, I think error X or something. You can also just use a function like this, various versions of these functions to print errors. So these are nice. You can basically display a formatted error message in standard output.
I mean, it combines basically printing an error message with exiting the program with printing the error no value. The amount of places that I've had an if statement where it's like if some condition, then I have to open up races just to say, printf to standard error, a bunch of stuff, get the, p error, right, and then exit. And it's like that, that can all just be done. Right? Here's an example, yeah. And so there, the X is not going to include the error no value. And then the one there, if the open fails, it's going to give you, if file descriptor is -1, it'll print, it prints the name of the program, a colon, then the message, the format string that's inside of the arguments, and then it prints a colon and a space, and then the string description of the error number from p error, and then it exits with the exit code, which is the first thing you provide. So very, very handy function.
Yeah, and that makes it easier because otherwise you'd have to do, what this is from error.h. So, otherwise you'd have to do something like, I don't know, it's some garbage here. But like if, val, syscall, whatever, error, syscall, failure to perform, whatever, and then exit. I don't know. You can give it some interesting exit code, or just like exit 1, whatever, right? And so you have to use the brackets, and it takes more space, right? But then, and this you'd probably need, pure, I think, something like that, or like uniscd, whatever it is. And this would be. I mean, I'm not even gonna bother making a function. And then, as you could do this one, right? The clunky way, or you could do it the smooth way, which is just if syscall xxx, and then who cares about brackets because it's one line. You can just do error 1 failure to perform, and then slightly cleaner. You just need to remember to include error.h. Right, this is roughly correct. I'm not going to test it.
Yes. Yeah. That's correct.
So, yeah, that's the difference in how you would use it. And so you'll be doing these things a lot. So it's an important thing to mention. Your shell, you have env. I'll show you all these the stuff that's going on in your environment, right? So if I say foobar, as whatever. Oh, no,
you got to export it.
Yeah. Otherwise, we'll just do for that local command. So if I set something, that'll be in my env, and so man1 env, basically, pretty sure just runs like get env. I don't know if it mentions it. So man2 get env. It's 3.
Yeah, because it's not a system call. It's all in user space.
It's just in the local environment. Just returns a pointer to the value in the environment or null if there's no match. So we'll just return a string. I could even do a demo with this theoretically, but this is a very simple one. But that's just an example of the environment, right? So it's important. If you don't do the export, then it won't show up, right? If you're doing it in like a that's why people do so you could do it for like a local command, like if I have script.sh, running the script, just echo hello, foo dash. So right now it's just going to say hello, and I'm like, oh no, I want to say hello. What is it? It's foo. So foo equals, Charlie. like, okay, I want to say hello, Charlie. Oh, it didn't do it, right? And that's because and if we grab foo, we only have foobar, which is not what we're looking for. And we can
Yeah,
even, we can even say it in the script, but
yeah, it's
or I
basically
can
just a
just export it.
variable. You don't actually need to put the variable like name again. You can just do export foo. Like the foo does go somewhere. It's just only in the shell. But
Yeah, it's
be
only in
clear,
the
like
shell.
none of this actually is stuff that you need to do in your shell. I mean, your thing just needs to read getenv. Like you don't need to support setting environment variables. You don't need to support like most of this stuff.
Yeah.
These are all simplifications, but whatever. We're just showing how you can manipulate environment variables in a shell. In theory, you can also manipulate them in the C program. Yeah, that would be getenv.
Yeah, just demonstrating kind of what the concepts are. And you can implement as much of this as you want, and that probably will count in your favor if you do it. But do the basics first. Simple example, which you've probably seen before. We have like a data file here. X X X Y Y Y Z Z Z. Okay, and we can say cat input from data. I can also say output to data 2, and now data 2 is going to contain. So right, we just took in cat just concatenates data. We could even we could take just replace standard in with data, and standard out instead of printing to the screen, it just outputs to data 2. So basically, just re-implemented copy using cat. And then the last one is to implement support for the pipe. So you can take the output of one command, the standard out of one command, and link it to the standard in of the other command. And there's a system call for this called which takes in an array and gives back 2 file descriptors, and then you write into one file descriptor, and it'll you'll be able to read out to the other one in the other program. Right, and it's unidirectional. So one end is the read end, one end is the write end. It's not bidirectional. There's other ways to do that, other interprocess communication, which I think is covered in some of the OS classes at UMass Lowell, and on the internet in general. Just looking to interprocess communication. So bonus stuff, you can add support for the command terminator semicolon, which you can string multiple commands on the same line, so you can use this in Bash where you have, cat, data, and then echo hello, sleep 1, echo goodbye, good bite, yeah. Special characters, you can look at the man pages for these. Reading environment variables using name in general, right? So you could like dereference a variable, right? And as we saw, right, in this environment, we do foo, we get Charlie. If we do foobar, we get Baz. So same sort of thing, some kind of support for that. Modifying environment variables, like we just looked at, that's something you could add. Jobs, FG and BG, and background processes if you want to get advanced. Source, if you want to like load a bunch of commands from a file, that's pretty good. Source is also equivalent to dot. Have you ever seen that? Just the dot. And control flow, if you want to do if, else, loops, various things like that. And at the end of the day, submit this as a patch set as before. Ideally, you submit each patch each patch should complete a level individually. If you don't rebase this perfectly, it's not the end of the world, but the ideal submission has one patch that adds level 1, one patch that adds level 2, one patch that adds level 3, and each patch says which level you've completed, or like what in that, what part of the levels is implemented and where and how, just very briefly. So, and you can use git commit amend or potentially rebase to fix this. If you're hurrying to submit this and you just squash all together, it's not the end of the world, but it's not as ideal. And of
Well,
course, cover letter.
I don't know. Like, I mean, I
Please
think
don't
that,
send just one huge squash commit because that probably
Yeah.
would be kind of annoying to read.
well, yeah, and well,
And part of it
okay,
is for the
so
practice. What?
you can have more than one commit per level, but like ideally, a good submission will try and clean it up. Sometimes maybe it makes sense to have more than one commit per level, but like try and make your Git history tidy. Try not to have a bunch of commits that are, oh, do this thing, oops, it doesn't compile, fix mistake, fix mistake 2, fix mistake 3, and then like another commit where you do something and whatever. Like, you should, the commits should, the code should compile after every single commit, right? It should like roughly work. It may not, you may be slowly building up to some feature, right? But like you should be making forward progress in each commit instead of like doubling back and sort of, and the easiest way to do this is just to have one commit per level. But if you, for your own sake, you may want to make multiple commits per level, and in theory that could be okay to submit, but the commits should be tidy and work well. These bonus things, those are just suggestions. Like all of the you can do whatever you want. You don't need to do any of those things, and you can add whatever you want to the shell as long as it doesn't contravene anything that's said here. Whatever. Like hopefully this assignment is fun and interesting. Like it's not supposed to be. We tried to make simplifying sort of not assumptions, but simplifying choices. Remove, like there are situations where there's many different things that can be done, and we tried to just set one clear thing that take a slice of it and just be very clear and do this. The shell is much more complicated than whatever. There's just a lot of different features, but we tried to keep it simple. You're welcome to go and make it more complicated, but we tried to pick some things, and I think the piping is really this is both an opportunity to practice your C programming and also just to get familiar with some of the system calls, some of the ways that we interact with the operating system and make requests so that it completes things on our behalf. And yeah, if you get to the end of it, right, if you get to level 9, then you'll have used, probably 10 or more, system calls that are all very important and key system calls. And you'll, have really, gotten comfortable with C programming, made sure that you're totally on top of that. So, but we should probably move over to the kernel compilation soon, So
we got
there's any questions?
Any questions here? I mean, I'm kind of just all over the place because I'm not entirely sure what people want to know. Just kind of going down random rabbit holes. So, and just also remember, you write your patches so that someone else can read them. Yeah, separate patch. So you can't, one patch for 10 commits would be, each commit becomes a patch. Like that's kind of what a commit is basically, a patch. I mean, it may have a number of hunks, right? And those are the different parts of the diff in the patch, but 10 commits means 10 patches. And if you do extra parts, you could say, bonus added semicolon, added, the and or operators. I don't know what their technical name is, but that's what I'll call them. Various things like that, and write this so that someone else can review it. Like write this as if you're submitting this, to a public project, and it's going to be on the record, and because you're going to have to review other people's patch sets, so write it so that other people have a good time reviewing your patch set, because we'll just make everything easier, and makes it easier for us to grade. Well, we want to give you full credit, so yeah, we're here to help. If you have questions, we'll be around. We get started on this as soon as possible. Because,
ideally already.
What?
I said ideally already. Already started on this one, and both A1 and A2. You should probably start on both of them and sort of work on them in parallel, because we'll talk more about A2, but A2 is not particularly challenging. Like there's not a lot of active work when you're compiling the kernel. Pretty much you just try it, and then it takes some amount of time to break, and then you go back and fix it. And And so all that downtime while you're just waiting for the kernel to compile, you can be working on your shell. So we'll talk about, A2, but both of these should be somewhat symbiotic in that you'll have plenty of time to be working on your shell while you're waiting for the kernel to compile.